So here, I'll send it to you again. It's in the chat. Just sent it. Whenever you're ready, you can share it. And we'll start off with empty cells at the way top. Do you still need some time? If you want, you can go next. Then Albert, can you share your screen? Or Adam shared it. Okay. Okay. Is there a reason the whole file is like 1,000 lines long? Are you doing it in one file?
Yeah.
Mm, okay. So, okay. It's very hard to see, but starter. Can you go down to the function called empty cells? Yep, that one, yep. So this one basically takes in the board and returns a list of tuples. So it returns a list of row and column positions that are empty. So it's like the get available moves function from the tic-tac-toe. So if you can implement that. No, that was from tic-tac-toe. Yeah. So go to the raise not implemented there. It's on the bottom. Right there, right there. Line 945. Delete it. You're gonna want to delete the raise error, or else it's gonna error out. Yep. Now we want to set cells that we want to return. Cells is a list. It's not a function. It's a variable that you want to initialize. Yep. You initialize it to an empty list. Next, what do we want to do? We want to go through each cell and check if it is zero. Do you know how to do that? So Adam, one thing, the board is a size by size. So you're gonna want a 2D loop. So how would you go through each cell in this board? Do you know? Well, one thing you can do is double for loop. So you want to go through each row and column, right? So first, let's go through each row. So that would be for each I in range size. So just I in range size, or you can also do R which is better since we're going through each row. So for R and range size, yep, colon. Oh, you forgot a colon there. Yep. Now we want to loop through each column inside of that row. So we want to go through 4C. You were right. Yep. In range of size. And then we want to check that cell if it is 0. So if the board's R row and C column, so that's that one cell, is equal to 0. So it's checking through each cell, right? Because you're checking each row, you're checking each column, and you're checking if it's 0. If it is 0, then we want to add it to the cells because it's empty. Yep. Implement. You want to append to cells, yeah. And you want to append the tuple.
What do I put here?
Append is a function. So do you know how to call a function? Circle brackets, right? Yep. And then you want to place in that circle bracket the tuple of row and column. So you're basically passing in a tuple of row and column into the function called append. Does that make sense?
Yes.
Okay. Now, lastly, what do you want to do? You want to return it. One more down. Yep. Any questions here? If not, you can just stop sharing and Albert can go next and we'll implement add random tile. So Albert, if you can share your screen. So you're gonna have to go to code week 5, 2048 base. Yep, that one. You're gonna want to go to add random tiles, the second function from the top. Yep, line 48. So this is a function that takes in a board and returns nothing. So it's basically a void function. We want to place a 2 with a 90% chance and a 4 with a 10% chance on a random empty cell. And then you can basically implement it. So first you want to call empty cells, which is the function we just implemented, and get a list of free positions. You pick one of them randomly, and with a probability 0.1, you write 4. Otherwise, you write 2. First, let's delete the raise not in. Okay. Uh, so yeah, first you want to call empty cells. You want to check if it's empty, and then you randomly choose one of the empty cells Do you basically know what's going on? You can also just write in the VS Code, mostly. Okay. But you basically, for that last line, let's delete it. Line 63. Yeah. Tab or four space. But here, why we don't, no, 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 no. Yeah, just go to the line where the RC is, like space four times. No, no, go down, space four times. Yep, there we want to do if space random dot random. Yeah, okay. Basically, random dot random. Do you know what that does? Does anyone know what random dot random does? Picks random. Yeah. Do you know what it picks from? Like, what is the possible output of random dot random? Yeah, it does choose a random number, but it's more specific than that. It chooses a number between zero point 0.0 and 0.1. Yeah, Kaden, you were actually close. So it's zero point 0.0 to 1.0. You're right about it being a decimal. So it basically chooses between 0 and 100%. That's why it's doing random.random is less than zero point 0.1. So if it is less than 10%, then we do 4, like place the 4 inside that cell. Otherwise, not with a 90% chance you place it 2. Does that make sense? Yeah, okay. Then we know that this is a void function, so it doesn't return anything, but we can also, just a good standard way is just write return. Not there. Do you know why you can't write return there? Yeah. Okay. You can stop sharing your screen and Kaden can go next and we'll do another function. So we can do init board. So this basically creates a fresh board with start tiles, random tiles. So at the start, we're gonna call random tiles sometimes because we want to start off with something. And one thing though, you want to set the board first. So let's initialize the board. That would be a. Actually, you can do that. You can do that. If you want to set it as a variable, you can do that. Yep, equals, and then remember that you can just place it as an empty list, not a tuple. Yep. Now we want to make the lists. So it's basically a 2D list. So first you have that number of rows. Now you want to add rows to that board. Size. All caps size. Size. Yeah, sorry. It's because at the way top we set size to 4. So one thing here, I do get the idea, but first, okay, let's delete the line 83. On line 83, this current one, press enter at the, yeah, to create a new line after that. Yep. Now we want to create a temporary one here. So do like temp row equals a list. Now we want to add a 0 for each C. So for C in range size, do temp row dot append 0. Yep. No, integer. Yep. Now at the way end, after that for loop, enter, uh, subtract. Yep. Now we want to add that temp row to the init board. So do init board dot append temp row. Yep. Good job. Now that should initialize the board, right? Now we want to do the start tiles. So we want to do enter, enter, uh, subtract. Yeah. Now for each, I don't know, I in start tiles, we want to call add random tile. For I in range of start tiles, we want to add a random tile. And if you hover on it, it says right there, board. You want to pass in the board. And it returns nothing, so you don't need to initialize it. Remember that it's init board since you named that variable like that. Yep. And you don't call it because it's not a function. Yep. There you go. Now you want to return the board. And if you hover on the start tiles, it'll say literal 2. So basically it's 2. And if you hover on size, it's literal 4. And if you go all the way up top, scroll all the way up, you'll see the size is 4 and start tiles is 2. So it should be good. Now that's it for init board. So let's move on to compress. So James, you can share your screen. Although, are you able to share your screen? Okay. Then I know that Nicholas can't do it today, so we'll just go the other way then, from Caden, Albert, and then Adam. So let's do Caden first again, and we'll do compress. Okay, sounds good. Then, yeah, Caden and then James. Yeah, that's all right, James. Yeah, sorry, Caden. You guys will be doing it a lot more today because there's only three-ish people doing it. So let's move on to compress. So this one, what you have to know is basically we want to merge equal neighbors, or actually slide, that's the merge. For compress, it's slide all non-zero members to the left. So basically, if you have 2024, we want to slide the 24 down. So it's 224. But it doesn't merge it together. So if you want to start it off, we'll basically create a new row first. New row, set it to a list. Yep. hmm Now here, if the rows like R cell does not equal 0, then we want to add it to the new row. So one thing here, you want to check if it is not 0. So you're going to need the conditional. Which symbol is not? Do I need? Oh, so you need the if. So delete the init board. Do if. Yep. If row. Oh, or yeah, rows are. So like the row square bracket R. So the rows are cell or are column of the row. Make sense? Does not equal 0. So we want to check if that cell of that row does not equal 0. So not equals is exclamation mark. So exclamation mark equals. Yeah, that's the not equals. So you'll learn in Boolean logic later that exclamation mark is not and equals is equals, so not equals. Next, we want to append it to the new row if it is not 0. Yep, yep. Next, we want to fill the rest with 0. So enter all the way down to the for loop. Delete. Delete twice more. Sorry. You need to move down to the line where for loop is. So like delete it, delete it. Yep. And then tab. Uh, yeah, right there. Because after the for loop, after we move all the integers down, so this new row has all the integers lined up, we want to set the rightmost to all zeros. So let's do like while length of new row, len is, yep, new row is less than size, colon, we want to append 0 to new row and then return new row. So you see here, we append all the integers to the new row. So we shift it all left and then we pad it with 0. Make sense? Sounds good. Next, James, are you ready? Or Sure. Okay. Next, we'll go on with merge. So it's like, yep, right there. So merge basically happens after we compress. So we moved all the integers down to the left. We have the zeros on the right. So now we want to see if there's two numbers that are the same. If they are, we want to merge it together so that 2 equals 4, and then the right side becomes 0. Does that make sense? Yeah. Yep. Now we want to walk through the row with an index from 0 to size -2. And if row I, so that cell is not 0 and equals the right side, then we want to double the left side and pass that as the score. And basically we return that new row and that pointer. So we want to delete the arrays not implement error, so line 101. Yep. So now for loop through it. So we'll do for I in range, yep. 0 to, yep, that's good. Length of row. A better way would be just doing size, since we already said. So just do all cap size -2. Actually, no, -1. Do you know why it's -1? Yep. Well, good job. So everyone who didn't get it, since we're checking two pairs, the last one will never have a right side. So we don't check it. Yeah. Okay. So we check each cell of that row and we want to check, is it 0? If not, then is it the same as the right? So let's do like if it does not equal 0. Yep. Does not equal 0. And the row's current equals the row's right. Yep. Then we want to set the current to double the size. Yep. And we want to set the right side to 0. And then we want to add that score. Add that to the score. So actually we should set the score at the top. Yep. Equals 0. And then we set that score, add it. Yep. Plus equals the row's I. So that cell's, yep, number. And then we want to return the row and score. So we return a tuple. Return the row and score. Yep. Good job. That's it. Thank you. Any questions there? If not, we'll have. Thank you, James. Although I don't think they can copy it because it's Zoom. Anyways, Albert, if you can share your screen, we'll move on to move left. Do you mind maximizing the screen? The VS Code? Sorry, I meant the like square button at the top right. Okay, that works too. Okay, so move left basically executes a left move. So it basically uses the compress and the merge and then compress again to move, like simulate that move that the player makes. So you can go ahead and implement it. Um, so for each row, okay. Mm, you could use AI, although, yeah, let's just explain it one by one then. So basically, for each row of the board, we want to compress, then merge, and then compress. That's what you see on lines 149 to 151 on your screen. And then after we do that, we want to add that row back. We want to update the score. And if any row has changed, we set the move to true. Yep. And then we return the new board, the total points, and the move flag. Do you understand that? Okay. Although we probably shouldn't use AI, but it's fine. Next, Adam can share your screen.
Oh, I'm not done copying the other one yet.
Okay, sounds good.
Can I see it again?
Do you want to try implementing it?
Okay.
Okay. It's up to you. I can just show it again too. Up to you.
Okay, what is it?
Okay, I'll share my screen. So here it is. So you basically initialize the move, the total score, and the new board, which is a double list with an integer. And we check each cell. We do compress, merge, compress again. And we want to set the moved flag and then add the total point, add the new board, etc. Although one thing here, this while loop can be changed. Paste bin. Oh yeah, right. You can paste. So Adam has the code as well, but basically this while loop we can change it, right? So we want to do for each row in range size. We want to delete this, and that should be good.
Okay, I'm ready to do the next one.
Sounds good. Share screen. So here we want to do rotate. Yep. So basically we want to rotate the board 90 degrees clockwise. So you want to create a new empty 4x4. So just call that rotated board and basically a empty list. And then for each cell, which is row and column tuple, in the original board, we write its value into the new position in rotated board. So we're basically creating this new board that has been the original board's rotated 90 degrees. Does that make sense?
Yes.
Okay. So you guys haven't learned it yet, but the solution is right there. Basically, each new position will be C, comma, size -1 minus R. And later on, you guys will know that this is a inverse matrix, but you guys don't need to know that. Yep, for each row and column. Yep, for each row and the size, you create a new row. Although, yeah, sure. And then for each cell, I mean column, in the range of size, you want to add the new board, new row, which is boards, column, and size -1 minus R. Yep, new append. Not zero. It would be C, comma, size, all caps, -1 minus R. Yep. No, not there. It would be, yep, right there. Yep. Rotate the board, dot append, this new row. Yep. Now we want to return it. Yep. Good job. Good job for subtracting there, or backspace. So here we're building each row one by one, rotating it 90 degrees, adding it back into that rotated board, and then returning that rotated board at the end. Does that make sense? So we
Yeah.
can, yep, okay. How should we do this? Yeah. Do you want to just make another function? We'll just keep rotating each person. Next, uh, Adam, do you want to do it again? We'll do it, keep going like this.
Like what?
So we'll go from Adam, Albert, Hayden, and James, and then James, Caden, Albert, and Adam, and just keep going. Next function is move. It'll be really easy. So yep, now let's set. So this basically performs a move in that direction. So let's say you have up or down or left or right. So we want to map each directional move. So left is 0 rotation, down is 1 rotation, right is 2 rotation, up is 3. The reason we're rotating is the main move that we have is move left. So if the user clicks left, then we don't need to rotate and just call move left. If we want to move down, then we rotate the board 90 degrees and then move left. Does that make sense?
Yeah.
Okay, then let's actually map it out. So let's do uh rotation equals like -1. Yep. And then we'll have like a switch statement, but let's just do if and do that for each rotation. So direction is left, then rotations equals 0. Rotation is equal 0. Yep, just keep doing that. If it is down, then it's rotation 1. Right is rotation 2. Up is 3. And at the end, we want to check for else. Else means it's not a left, down, right, or up. So we want to throw or raise an error. So else, colon, enter, raise a value error. Yep. And say like invalid direction. So now we want to go on to number 2. We want to rotate the board that many times. So we already have a rotate function. So do enter, backspace, tab. Yep. Now for each I or rotation in rotations, or like range of rotations. So do for loop for I in range of rotations. We want to rotate the board. So board equals, actually, we'll do a deep copy first. So go on to line 1125, tab, yep, TMP, temp, equals deep copy, TEMP, temporary, yep, TMP equals deep copy, yep, and as a function and pass in the board. Yep, good board, yep. So this basically creates a deep copy. Next, we want to rotate it multiple times. We want to rotate the temp. So we do temp equals, not board equals, temp equals, rotate temp. Since we already have that rotate function. And then we want to move left. So enter, enter, uh, tab. Now we want to move left. So we want to call the function move left, and we pass in the temp. And one thing you should know, move left basically returns the move board, points, and moved flag. So we'll have to set it to some variables. So before that move left function, like to the left of it, down, yeah, right there. Do moved board, comma, points, points, comma.
What's points?
So it's like how many points you earn from making that move. Make sense? Points, yep, and moved. So this basically says, were we able to make that move or were we stopped? So let's do a moved flag. Yep, equals. So move left basically returns three variables, and we're setting these variables to that return value. Make sense? Now we want to rotate the board back to its original position. Although, yeah. Rotations equals. One thing here, we want to rotate that moved board, right? So delete that, delete the rotations, and we'll do for um, I in range of, yep, uh, circle bracket, another one. Inside that, we'll have 4 minus rotation, and then to the, yep, rotation. Now right arrow, and then modular. Modular is this, the percent chance, to the right, in between the circle brackets, closing circle brackets, right there, yep. Yep, and then do 4. Does anyone know what that modular means? And it's a for loop, so colon. A- And I think you have to delete the equals -1. Delete the -1. Yep, good job. So the modular 4 basically means get the remainder after dividing it by 4. So say you do 5 divided by 4, then the modular is 1 because 5 divided by 4 is 1 remainder 1. So the remainder is 1, so it returns 1. So basically what you're doing is 4 minus the rotation. Rotation should be S because at the top you set rotations equals negative. Yep. So you're doing 4 minus the number of rotations we did and modular by 4 because we want to check how many rotations we need to go back to our original position. Yep. Now we do move the board equals rotate the moved board. So the reason why we're not doing rotating it by the number of rotations again is because we want to move 90 degrees other way, not the same way. Yep. Rotate move board, and then we want to at the end return the move board and the points and the moved. Make sense? Did that make sense, Adam?
Yeah.
If so, then Albert, can you share your screen again? And we'll do can move. So here we basically want to return true if at least one legal move exists and you can make it. So you already have a function for that. You want to check empty cells and you pass in the board. So if it is not empty, we want to return true. Otherwise, we want to try all the four directions and call any call to move returns true. Then any move is possible, so we return true. Otherwise, we return false. Does that make sense? Okay, then delete arrays, and we want to so first set a constant of up, down, left, right. So at the top, line 221 to 31, enter, and we want to do directions equals, yep. And then we want to pass in the directions in the for loop. The reason we want to do this is it's always better to not actually have the spread of the list inside a for loop. Yeah, that one. Delete it. Delete the list. You don't want to spread it. You want to do in directions. Yes. So here we want to check if there's empty boards, empty cells in the board, which we return true. And then last resort, we want to check each direction. So we do make a move, check if a move was made and return true, or else we return false. Make sense? But yeah, that's basically it. Next, evaluation. James, do you want to go ahead or Keaton? James, are you able to share your screen? What's the London bus company? I have no idea. But yeah, you can share your screen. Thank you, Albert. But yeah, evaluation, which is down, 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 down. You found me. Okay, evaluation. So basically, this is the heuristic for the expected max. Does anyone know what the heuristic is? If not, I'll tell you guys. So heuristic is important in AI. It's basically evaluating the points that we have right now. Or like, let's say a drone is, or like a boat, a float. Anyways, so you remember in tic-tac-toe AI, the evaluation was if we win, we gain 10 points. If we lose, it's minus 10 points. And if it's a draw, then that's 0 points. That's basically the heuristic there. The heuristic is that if we win, it's better. If we tie, it's worse. If we lose, it's way worse. So the heuristic here is different because here we want to get the sum of the tiles and we want to give more points to the number of empty cells because empty cells in 2048 is better, right? It's better than having a whole bunch of numbers in that 2048 board. So yeah, that's basically the heuristic. And heuristic can be anything. That's why there's like good heuristics, bad heuristics, etc. First, we want to compute the sum of all the values, and then we want to call the empty cells to obtain the number of empty cells. And then we want to return that heuristic. Make sense? This one's really easy. So delete the arrays not implemented there. Okay. Uh, do you know how to go from here? You want to compute all the sums of all the values on the board. So you want to go through each cell and add up all the board. So one thing you can do here though is you can just do range of size, all cap size, since we already set it, right? Yeah, yeah. It's just way easier. Yep. Now you want to add it. So something plus equals towards ij. Uh, One thing here, that one's, yep, yep. Now we want to call empty cells. So you want to go down to the first for loop, backspace, backspace, again. So here, after we add up all the sum, then we want to call the empty cells board. So, yep, empty cells board. And this basically returns the number of empty cells. And we want to, the empty cell basically returns a list, right? And since we only want the number of empty cells, we set it to the value. So equals, let's do like number of empty cells or, yeah, thing equals length of, yeah, good job. Now we want to return the float of, yeah, and then just do float of the entire thing. Float. Yep. Yeah, that's it. Good job. Next is the expect max, although uh, next, Kaden, if you can share your screen, we'll first actually do AI move and get best move because AI move is literally just one line. Go down, down, down. Yeah, right there. AI move. Delete the, yep, delete the raise. Basically, here you just want to call get best move. And we pass in the board and the depth, which is already in the function argument. And you see up there on the AI move, depth is set to 3. So yeah, and you want to pass in the get best move. Uh, One thing here, you don't want to return the get best move. You want to return something else. You pass in the board and the depth. Yep. And get best move returns a string, which is the direction. So the direction equals get best move. And then you want to return the move board direction. Like move of board and direction. Yep. Board, comma, direction. And that's in the function. So here, what we're doing, we're calling this AI move, which calls the best move, get best move, and you get the best move. And you set that move to direction and you make that move. Make sense? So this is the AI doing that move. So it thinks about the best move and then actually does the best move. Now let's implement get best move. It's above right there. So this returns the direction up, down, left, or right that yields the highest expected max value. So first, let's do best score equals the worst possible score, which is negative flow to infinity. Yeah, best score. Remember that. Yep. String. Yeah. Yeah. Good job. And then do best direction equals some random value. You can just do up or down or left or right. Anything. Best direction equals up to you. Okay. Just do caps. Yep. And then enter. Now you want to set a constant of the available directions. So just do directions equals a list of up, down, left, and right. Oh, just copy and paste it from above, I would. Yeah. There's no need to spend too much time on that. Now we want to go through each direction in up, down, left, and right. So do for each direction and directions. Now we want to make a move. So just move, and we pass in the board and the D. Yeah. And this returns the board, the direction, and the moved. No, board, points, and the move. No, no, no. So the move function returns that. So you have to like get it. No, no, no. So that's the argument. To the left of the move, uh, yes, right there. There do new board or board, anything works. New board, comma. This one you don't need, but you can just set it to underscore, comma underscore, underscore, comma, moved, moved equals move, comma equals, no comma here. Okay. Do you get this here? You call move, you get the new board, the underscore, the underscore is basically the score gained, but we don't need that right now. So we're basically doing, okay, we don't care about it. Underscore. Yeah, that's what that is. Now check if moved. Then we want to call expect max. Enter expect max. We pass in the new board, def -1, and false. So that's basically the board and the depth and which player it is, but we just do false. And the expect max returns a score. No, no. Uh, you you do score equals expected max because the expected max returns that score. Yeah. Yeah. Now we want to check which one's better between board and the score. Yeah, best score and the score. So do if the score is better than the best score, then we want to replace the best score to be equal to score or the best direction to be equal to the direction. So do yep, best score, then best score equals score. And by yep, equals current direction, which is D. Yep. Enter and we enter backspace once more. If you want, you can print something, but you don't need to return best direction. Also, one thing here, in the expect_max, you're calling the board, you need the new board. Because this is after the simulation, right? Because line 349, we're making that simulation. Line 351, we're evaluating that simulation. And inside the move, you have a comma that you don't need. Yeah, that's good. But yeah, that's it for today. And we'll do the look at. Let me share my screen. Can you guys see my screen? Okay. Anything you guys want to try? The link is in the chat. And I'll give you guys 1 minute to join up. And I'll stop the recording.